Hi, welcome back. Today we're going to be doing the electrolytic reduction of nitroguanidine to aminoguanidine because it's nowhere online and a lot of people want to see it. We're using these lead discs I cast as electrodes. They were just made from air gun pellets. So we've got that one is the cathode, which is going to be where the reduction is taking place. We have this flower pot to act as a membrane. We have a bowl to act as the anode compartment, and another lead electrode. Those are going to go in this cooler with some ice packs. I've got a hole cut in the top to let out hydrogen just so it doesn't build up, and if it for some bizarre reason sparked and popped, it's a styrofoam cooler, so it's not going to matter, it'll just blow it apart. All right, so we've got to make some solutions to use as our analyte and catholyte. And we're going to be using ammonium sulfate, 30%, as the catholyte. And we're going to be using sulfuric acid, 10 to 15%, as our analyte. All right. What else do I need to say about this? We're going to give the electrodes a little bath in some dilute hydrochloric acid first, just to make sure they're all clean. And yeah, so let's get to making this. All right, we need about 22 milliliters of this 90% sulfuric acid. This stuff comes as drain cleaner from Walmart. It's not terribly expensive. Oops. We overshot a little bit, but that doesn't really matter. You just want our catholyte to be acidic. Water in. Get that stirring on. And then we'll just add our sulfuric acid. Doesn't really matter like how fast you do it with this amount. It's not going to get overly hot or anything like that. So there, we've got that. So we can take that off, set it there. And I need another beaker. I'll be right back. All right, we're back. You probably see some traces of nitroguanidine in there, but it's not going to matter because that's all going together in the end. We have 90 grams of ammonium sulfate. This just came from fertilizer. I recrystallized it, but it's probably not even necessary. And we're going to make this 30% solution. This also likely doesn't need to be exact. Electrochemistry is kind of got some broad ranges of conditions where things will work. Though I haven't done this one before, so we'll see what happens. All right, I'll come back once that is fully dissolved. Okay, I broke the camera clamp on my tripod, so expect this to be a good bit shakier after this. We're going to put together the cell. We've got everything. We've got our electrodes taking a bath in some hydrochloric acid, just dilute. We've got our ammonium sulfate, and we've got our 10% sulfuric acid. Our flower pot as our cathode chamber, and just a regular plastic bowl as the anode chamber, and a cold pack because this needs to stay a little bit cool. Here we are. We've got an ice pack and an ice bath, the bowl with the analyte solution of sulfuric acid. We've got the catholyte solution of ammonium sulfate, and we've got 30 grams of nitroguanidine in there. We're going to turn this on, give it 5 volts, 3 amps, or approximately 5 volts, because we're going to use constant current. I'm using a power supply that I got from Amazon. It was like 60 bucks, but technically, there are phone chargers that put out 3 amps and 5 volts. So this could be done as ghetto as humanly possible. Okay, we're getting some bubbling. It tells us that it's working. It's running about 5 volts, 1.6 amps. Oh, That'll go up over time, just as the permeability of the flower pot, like basically once it gets soaked in our solutions. So yeah, we'll come back in a while and check on this. Basically, we run this until we can't see any more nitroguanidine. That's 30 grams in there. So we'll be back in a while. All right, so it's running smoothly. I'm smelling ammonia, which is supposed to happen from the cathode solution. Oh, there are my fingers in the way. Just a little tip with electrolysis, like unlike other things in life, make sure you panic. Positive anode, negative is cathode. It's just an easy mnemonic for helping to remember that. We're going to come by and give this a little stir every now and then just to make sure the nitroguanidine's getting in contact with the cathode. I do have this sitting on top of my hot plate with a magnetic stirrer and everything underneath it, but it's really just making the stir bar like twitch in the bottom. It's really not doing too great, so we're going to do it manually. Over here, I turned the voltage up a bit to give us 3 amps, and yeah, we'll come back and check on it every now and then. Okay, it's about 5 hours since we started. I've been giving this a stir every 20 minutes, half an hour or so, just because the stirrer, I've got the hot plate underneath, isn't working up through all this. We're starting to see like most of the nitroguanidine has broken down. It's still a little thick, but I think what we're gonna do is I'm gonna run it until there's absolutely none visible, and then a little bit longer, just because I assume there will still be tiny crystals left once there's none visible. So we're gonna keep that running. It's trucking along. Replace the ice pack just to keep it cool. It only needs to be about 20 degrees Celsius. Under that, like, your yields do get better, but it's really not enough to really care about. All right. Okay, it's been about half an hour, and I came out to check, and the temperature had jumped up considerably. So I've thrown some ice and salt into the cooling bath portion and a couple more cold packs, and I've got the power turned off just for a little bit to let it come back down to a reasonable temperature. I'd say I didn't use the IR thermometer gun, but I'd say it's probably about 25 degrees Celsius in the cathode container. So we'll just let that chill down a little bit, and we'll get it turned back on. There was no like real increase in like voltage or anything like that, like I would expect from this power supply when trying to constantly run 3 amps. But yeah, I don't know why it did that. All right, see you in a bit. A little bit warmer than I wanted it to be. And it wasn't cooling off very well, so I swapped the plastic bowl for a glass beaker for better heat transfer, added some more analyte, the sulfuric acid, and I put it in this big like pickle bucket. And because of that, I've been able to turn it up to about 10 amps per decimeter squared. And yeah, it's trucking along. If I had stirring going the whole time, I think this would have been done by now. It's just a matter of me like giving it a stir, and I've been babysitting it for the past couple hours. All right, see you in a bit. Okay, it's 1 in the morning. I'm gonna shut this down for now. We're gonna lose a little bit probably to hydrolysis overnight, but I can still see a little bit of the nitroguanidine in there, and just let it sit, turn it off, and let it sit, and I'll run it tomorrow until I don't see the nitroguanidine, and then we'll process it. Right on. Okay, my anode fell off in between the beaker and the flower pot when I was stirring it, so I figured I'd have to take it apart anyways, so I was just gonna filter it. And our solution, I don't know if this is showing up on camera, but it's sort of a pale yellow, which is indicative of aminoguanidine. There is some nitroguanidine left, but I don't think it's anywhere near the 30 grams that we had initially. So I'll just recycle that into the next run. I'm gonna insert your favorite racial slur, rig my camera holder back up, and we'll get to bubbling some CO2 through it. Okay. Okay, got the camera rigged back up. I've got a CO2 generator that's just hydrochloric acid and an arbitrary amount of baking soda. And I use these little air stones for anything involving gas, like, or anything where it needs to be really absorbed, like ammonia. They're like $2 a pack. So let's give this a little acid. I don't have a pressure equalizing addition funnel, so I have to turn this on and off. I don't know if that air stone's going to work with this. Oh, it's doing it, just not well. I might have to remove that. So we're supposed to adjust the pH to 9, and right now, oh, take the cap off that. It's 7.58. These are great, especially if you're colorblind and you're always running out of pH paper. They're cheap. You can get like a decent one for like $30. So yeah, it looks like this is gonna be just a lot of turning this on and off. Okay, I'm not gonna waste your time watching all of this. I'll come back to this when it's at approximately the correct pH. You probably do this in sodium bicarbonate, just directly into solution too. Okay, I closed off the top of the gas generation apparatus. I didn't want to dig around for a stopper, but I just used a glove and an elastic band. So it's just giving out pulses of CO2 here. All right, we'll be back in a little while. I see that a lot, don't I? Okay, so I just pulled this out of the freezer. It's not done precipitating yet, but it definitely worked. Okay, so that worked, and I think this is the first video online of this process actually being done. There are pictures on Science Madness and places like that of the reaction, but there's no video. I'm not going to do the yield and everything like that right now because there was leftover nitroguanidine, and this is more proof of concept and showing people how it's done rather than how to do it exactly right. Like ideally you should have stirring going on. Next time I do it, I'm going to do it with a tin cathode, and I'm going to make it like an L shape so that the bubbles are coming up from the bottom, so even if I don't have stirring, that'll continually sort of circulate the solution, and it should go a lot faster. Tin has better hydrogen evolution than lead does. A couple of things that weren't, or a few things that weren't tried in the paper were MMO, like mixed metal oxide electrodes, platinum, and lead dioxide. I have all of those. They also didn't try titanium, so I have all of those, and I'm going to be trying those out and seeing how much better we can get it. So I'm going to recycle the last little bit of nitroguanidine into the next batch. But the main thing I want to talk about now is waste. So we're talking about lead, and spreading lead salts and stuff like that in the environment is a dick move. So I'm going to reuse the analyte, the sulfuric acid solution, and I'm going to store the catholite solution until I have enough of both solutions, that I can combine them and then use like low current electricity to plate the lead out of solution. And or you could find a non-water soluble lead salt or something like that, because you just don't want to be spreading that around. It's mutagenic. It's not good to have around. Makes kids functionally retarded. Well, actually retarded, really. But yeah, so just don't throw your lead waste away. Like there's some lead dioxide produced in this for sure in the cathode compartment, and at least a little bit in the anode compartment. And I believe there's lead sulfate that's going to be produced as well. Um, Electrolysis reactions are like stupid complicated when you try and actually map them out as far as exactly what's happening and how many side reactions there are and intermediates and stuff like that. So I'm not even going to try to get into explaining exactly what happens here. Basically, just hydrogen is our reductant, or a reducing agent rather. Um, so yeah, I have trouble wrapping my head around a lot of electrochem, like actual theory and stuff, especially when you get to more complicated molecules or organics and stuff like that. But this seems to be a much easier and much higher yielding method than the zinc reduction route, which I'll also do a video on. But this is my go-to method for making aminoguanidine now, which has all sorts of cool uses. I'm sure if you're familiar with Dugan's channel and his NAP videos, there's that. It's used to make glow stick precursors. It's used in medications. It's used as a medication, questionably, but it's got a lot of uses, and it's a good precursor and like intermediate to all sorts of things. Um, it's expensive. Like thankfully, Backyard Science 2000 hooked me up with about 30 grams of it a while ago, but I have recently come down to my last half gram and had to get off my ass and make it. So yeah, I'll be testing out the other uh, cathode materials, and we'll see what works best and try different electrode shapes and things like that in order to get like the maximum surface area working at a time. Basically just try and optimize the system. All right, see you guys in the next video.